factoring trinomials. So trinomial means 3 terms. They're going to be in this form: ax squared plus bx plus c. A, b, and c are numbers. Let's see. When a equals 1, it's more of the easy case. You just have to look for 2 numbers that multiply to get c and add to get b. I usually do this, and I put the number here and here, and we write it down. That's how I do it. But by the way, for these, there's a lot of different methods for this and the next one. So I don't care how you get there, as long as you get there.
Don't some people split the box and then they do like there's like a box.
Oh, like something like this.
Yeah, and then
Yeah, I don't do that, but I feel like there is something.
Yeah, that one. I think I've done that one.
So whichever method you want is, as long as it works, it's fine. Now I'll do one of those in a second. There's also the case where a is not 1. So the easy case is just 1x squared. Yeah, that's the easiest. When a is not 1, like suppose it's 4x squared, and then plus 2x minus 3. Yeah, b and c can be negative as well. I guess so could a. But really, if a was negative, the first thing I would do would be to factor out a -1. So then it's positive. So usually a is not negative. But if it is, I would factor out a -1. GCF and go from there. Okay, there's a variety of methods for a not being 1. I'll show you 2. There's more. So whatever you're used to is fine. And I say here, remember to always do a GCF first. So even if you're doing this method, look for a GCF first. Okay, let's try one where a equals 1. So this is a 1x squared minus 7x. And by the way, this is supposed to be a minus 8. Sorry about that. Can you change that?
Okay, what? Minus 8.
Now here's factoring when a is 1. You just put your parentheses in. You put your x in. Let's get your confidence going. Right, we're doing that.
Oh yeah. Deckard.
I like that. Get your confidence going here. And then, okay, we look for 2 numbers that multiply to get c. I write here, so that'd be c is -8. And add to get b, which is -7. And then I just write the 2 numbers we choose here and here. So what 2 numbers multiply to get -8 and add to get -7? So 1 and 8, 2 and 4. So you would say -8 and 1?
Yeah.
Yeah. Multiply to -8, add to get -7. You put those in, make sure you're positive, put a +1 there, and that's it. And for all of these, you FOIL if you want to check. First, outside, inside box.
So wouldn't that be x equals -1 and then 8?
Oh, if you're solving an equation. If you're solving an equation, you get it to be equal to 0. Then you can factor it, and then your final answer will be 8 and -1. But we're just factoring, so we get to this step, and that's it.
But on lines you can't have a negative. So like.
On what?
Do you remember the one time that we would do stuff like this, but you have to get the x, or you have to solve it, but it couldn't be a negative.
Oh yeah, when geometry, it's like maybe a quadrilateral or a triangle or something.
Yeah.
And we'd solve it, but then we'd say, well, we might get x equals a and -1. Well, we can't have -1 for like a side length, so we'd often throw that one out and just keep 8. Here, we're not even going that far at all. We're just getting there done factored form. Good question. So any thoughts about a equals 1, that example? Let's go to when a is not 1. I'm going to show you 2 methods. There are others. Split the middle. A lot of teachers here teach this one. I actually favor method 2. But method 1 is a nice algorithm. It will work every time. Okay, you just follow the pattern. It will always work. Now, I should say this. Assuming, when I do the work, that you can get 2 numbers that multiply and add to get the correct value. If you don't, then it's probably prime. It's not factorable. But if it's factorable, this will work every time. It's nice. So split the middle. Here's what you do. You multiply A and C. Now we really did this back here. Okay, so back here you really multiplied A and C. 1 times -8. Okay, we really did that. You always just, but I don't really say that. You just look for the C and then add the B. So we're really multiplying 1 times -8. Here, let's do that. Multiply 3 times 4, A times C. And we get 12. And then I just do the same process as before. 2 numbers that multiply get 12 and add to get 8. What's it going to be? 6 and 2. They multiply get 12, add to get 8. Okay, now I basically did I did these 2 steps. Multiply and then add to get 8. Here's what we do. This is the split in the middle step. You keep 3x squared and 4. Okay, so those just come down. But you split the middle term, 8x, into 2 terms that mirror 6 and 2. Okay, so again, that's where the name comes from, split the middle term. 8x, we're going to now go write it as 6x and 2x. 8x becomes 6x and 2x. And again, how I got 6 and 2 was based on these. So 6x plus 2x is equal to 8x, right? That's the same. But I just write it like this. You don't simplify it, you just group. Now it's just grouping, and it's going to work. So I group the first 2, group the second 2, do grouping, and we're done. So for the first group, I would factor out a 3x. That's 3x. I divide, I'd be left with x squared over x is x. 6 over 3 is 2. The second group, the GCF is 2. So if I factor out a 2, I'd be left with x here, and 4 over 2 is 2. The parenthesis part, x plus 2, is the same. And so I factor that out, and then I'd be left with 3x plus 2. Okay, so that's the first method, splitting the middle. You take that middle term, 8x, split it into 2 terms, 6x and 2x, based on this, and then do some grouping.
Do you have to do a GCF?
Once you get to here, the 4 terms, you do you do grouping, which is GCFs. That you're saying.
So like, in the very beginning, like the first step, you can't, so like.
I would look for a GCF here, but there wasn't
So
one.
if that was 4.
If that was 4, yeah, then we would have done a GCF first, and then actually would have been a equal to 1 question. So, over there, yeah.
How'd you get like that equation for the final one?
That's when you do the third grouping is 3 GCFs. 1 was to get here, second one there. Third one is another GCF. There's 2 terms here, and you factor out an x plus 2.
Oh.
What's common to both? So I factor out x plus 2 and divide by x plus 2. The third GCF step. Let's see. Now I'm going to show you inspection, factoring by inspection. But again, there's other methods. I know at least one other good one. But Matt, any question?
So does it matter what method we use?
No. Just as long as you get it, I'm fine.
How do you know if A is 1 or not?
It's just the number in front of x squared. Here it was a 1. Just 1. It was just x squared, so there's a 1 in the front there. Here it was 3. So if it's not 1, then you have to do this method or a similar one. Yeah.
Okay, so for the for 3 on the method 1, does it matter what order you put those in?
You mean
Like the 6x
here?
and the 2x, when you add them together?
Oh, good question. No. I could have made it, thank you. I could have made it here, I could have put 2x here and 6x there. Still work.
But what if there was an equation where you could factor the parentheses? Could you switch them?
Now, if you do this part up here, if it works out up here, when you get down here, it's always going to, grouping will always work.
Okay.
Yeah. But I mean, we've seen grouping ones like yesterday where we're starting to group, it didn't work because we had them in a different order. But if you do this and you get two numbers that work, it will always work. So, good questions, guys. Let me do the same method with inspection. So let me write it down here. It's 3x squared plus 8x plus 4. This is, I'd say, a better method overall. It's faster. The thing about this, though, is because it's more of a guess and check, you could be sitting here a while trying to guess which one it is. And if you don't guess right, well, it might take longer. But if you're a good guesser, then it's going to be quicker. So here's what I do. This is how I often do factoring. I set it up like this. And then I say, well, the first term here, if I were to FOIL this, let me go back to this. If I were to FOIL this right here, right? First, x times 3x, I get 3x squared. Right, which is the first term. So right here, these two values have to multiply to get 3x squared. Or whatever, you know, if it was 5, it'd multiply by 5. 6x squared, it'd multiply by 6. So 3x squared, well, there's only one choice. 3 and 1. Whole numbers, that is. Right? 3 and 1. So I would put 3x and x here. That's the only choice. Let me say one note here. If it was like I don't know, say 12 or something, that'd be a harder one. Well, this one I'd do a GCF. But let's say it was 12 and I couldn't do a GCF. Because it could be 1x and 12x, 6x and 2x, 3x and 4x. There's many choices. But this one is only one choice, 3x and 1x. Now, then for these two values, I look at the 4. Because if I look here, when I do FOIL, and I look at L, so this is L, FOIL, the O and the I in the middle. So when I look at the L, the last, 2 times 2 got me 4. So basically what I do is work backwards and I think, all right, I need two numbers here, here and here, then multiply, get 4. Now we know it's going to be 2 and 2, but here's what you do, is you list factors of 4. 1 and 4 and 2 and 2. Those would be your choices. And now it's a guess and check. Let's say I didn't know it was 2 and 2, so here's what I do. I threw on 1 and 4. And then what you do is you do the O and the I in FOIL. So I do the outside and the inside. And watch what I get. 3x and 4x is 12x. 1 times x is x. That would combine to get 13, which is not 8. And that tells me I didn't do it correctly. I didn't choose right. Then what could I do? I could switch it up. I could switch it up and do 4 and 1. Now if I do that, 1 times 3 is 3x, 4 times x, that's 7x. It's not 8. So as you get better with this method and you become a better guesser, and even this, guys, I don't even write it down anymore. I just do it in my mind. I say 3 and 4 is 12, 1 and x is 1, that's not 8. Now, none of those worked. So then, none of those worked. The 1 and the 4. So then I tried 2 and 2, which we already know works. Right? 3x times 2 is 6x. 2 times x is 2x. That would be 8x. And I make sure I write positive 2. So you see you get the same thing here. Now, again, if you're a good guesser, and you get this, it's going to be a lot faster. If you're not, then it might take a little bit longer. Split the middle or other methods are fine or even better. So, any thoughts on the inspection method? Guess and check together.
So how are you gonna do a 2 and 2?
Because it worked when I foiled, and I mainly just have to do the O and the I, because I already know that these are going to multiply, get 4 here. But when I do the O and the I, this is 8x. The O, the outside 3x times 2 is 6x. Inside 2 times x is 2x. And when I combine those, that's 8x, which is what I wanted. When I did 1 and 4, I didn't get 8x. So I know that was not correct. Yeah.
So how did you get 3x?
This one?
Yeah.
That's when I flipped 1 and 4 around. I think I had 4 here and 1 here. And so the O was 3 times
Oh.
1, 3x, and 4 times x, 4x. That's 7x. So. Good. Any others? Let's try a couple on the next page just to make sure we're good. So I don't tell you which type it is. Let's do a few here. More examples. Factor the following completely. I should put in here if it's not factorable, you write prime. Now for these, all these were factorable, but not factorable, you write prime. Let's do 2. So it's a 1x squared. All I'm looking for then is 2 numbers that multiply to get c, negative 50, and add to get b, which is negative 5. Oh, and I can set it up. Put my parentheses in. X and x. So, any thoughts? Numbers that multiply to negative 50?
5 and then
Caleb?
negative 10 and 5.
Wow, Caleb, deep voice today. Negative 10 and 5. Those multiply to negative 50 and add to get negative 5. And that's it. Again, easy case when a is 1.
Wait, that's how you factor completely?
Yeah.
You don't do the.
Again, this is when a equals 1. That was the first case where it's 1x squared.
So you don't.
Done. Foil that, and you'll get the original. If you want to check.
Wait. Okay.
Yeah, just 2 numbers that multiply get c, add to get b. Let's do 7. So on 7, this is a not equal to 1, right? It's 2?
Yeah.
Well, kind of, but actually,
It's actually fun.
it actually is a 1 because I should always, always, always do a GCF first. 2.
So if you get it back to 1, then you just do it normal?
Yeah.
Oh,
So like,
okay.
now, here, I should mention on this one, you could do this as an a not equal to 1 question, but it's a little harder. And then then actually what you would get is that you'd have to do a GCF after you did that. So it's better to do a GCF first. So like on this one, just take out a 2. I'd be left with x squared plus 7x and then plus 6. Now you bring the 2 down, and then now I just set up my parentheses, put an x in each. 2 numbers that multiply to get 6, add to get 7. So basically I have 1 and 6, or 2 and 3, that's it. 1 and 6, yeah. So I put plus 1 and plus 6. Oh, the order doesn't matter there, of course.
Oh, I get it. Then you can't get it back to 1, then you have to do the middle order check.
Yeah.
Okay.
So let's do a couple where a is not 1. So we get on 2 and 7. Questions on those? So let's do 9.
No.
How does that, like 4 or something? Let's do 9.
Let's do
6.
4.
6.
4 would be a GCF one. 6 is good.
4 could be a GCF one. 15 doesn't do it.
Oh, sorry, 9. If I- Yeah, 9 would be. Right, because 3. Yeah, because you got at least the x in there. Yeah. So what method do you want me to do? We do one of the.
I don't know. Do this
The ones where
We're gonna try to split. Let's do one to split the middle, then I'll do an inspection one. So 4 times negative 15, negative 60. So again, yeah, if this is a not being equal to 1, you have to multiply 4 and in this case negative 15. You get negative 60. They must add to get the middle number of negative 4. So what 2 numbers multiply get 60 and add to get negative 4? Like I said, one of them's got to be negative. So which one? 10, yeah. Negative 10 and 6 multiply get negative 60, add to get negative 4. Okay, so you do not just write in x minus 10, x plus 6. What you do is split if we're doing split the middle, is you bring the 4x squared down. you bring the negative 15 down. And then you split negative 4x into these two. And like you said earlier, the order doesn't matter. I can put negative 10 first or 6, doesn't matter. I'll just go in the same order we wrote it in. So I'll just write negative 10x plus 6x. So again, that's equivalent to negative 4x, these two, negative 10x and 6x. It was based on these two numbers, negative 10 and 6 here. And now you just group them. So if you like grouping, do well with that. This is a good method for you. So let's see, the first group, I can take out a 2 and an x. 4 over 2 is 2, x squared over x is x. Minus, and then here I have 5. Here I can take out a 3. So 6x over 3 will be 2x, and negative 15 over 3 is negative 5. And the final step is factor out of 2x, running out of room, sorry. Factor out of 2x minus 5, and we'll be left with 2x plus 3. Let's do an inspection one.
Do 10.
Okay, I can do 10. I was thinking one where, like, I'm looking up here. Actually, 4, you gotta look at both numbers. Like, for example, if I look at 4, one of the numbers is gonna be easy. 2x squared. There's only, so if I can set up my parentheses here, there's only one set of whole numbers that multiply get 2. Positive, that is. 2 and 1. So like on this one, that was the easy one. That has to be those two. For 18 now, I have multiple choices. 1 and 18, 2 and 9, or 3 and 6. So sorry, I'm just going to do 4. And then what would 10 you want me to do? I'll do that as well. So then I have all these choices, and they actually have to multiply to get, add to get negative 15. So really I need all of these to be negative. And so then it's just a guess and check. And at this point, you kind of got to be a little bit smart when you plug them in. Like I kind of do a little bit in my mind, like what would work. Like in my mind, I do 2 times 3. I say, all right, 6. 6 times 1 would be 6. That's 12. So it didn't work. But I could turn it around and it might work as well. Did you have a question back there before?
I have a question about numbers.
Okay, yeah, go ahead.
I'm confused on why you don't just do the x minus 10 and the x plus 6.
It doesn't work. That's just not a method that works. When a is not equal to 1, basically that's the answer. Basically that's the answer to your question. A is not 1. If a is 1, then you just do that.
Okay.
If a is not 1, it wouldn't work that way. I mean, you could check by foiling it. It wouldn't equal it. So let's see. I mean, in my mind, let's see, 2, 18. Yeah, I don't think 1 and 18 is going to work. I mean, we try 2 and 9. Would that work here? 2 times 1 is, so I'm now doing the O and the I. 2 times 2, I get negative, or 2 times I get negative 4. Here I get negative 9. It's close, didn't work. What if I flip it around? 18 and 2. No, it didn't work. Looks like it might be 3 and 6. So let's see. How about I'll just put in negative 3, negative 6. See if that works. 2 times negative 6, negative 12. Negative 3 times 1 is negative 3x. And that one worked. Right, do we see how that would be negative 15x? So. Alright, you want to do 10? Let's do that one.
We don't have. Alright, so
No, I don't have to do it.
are we going to have to know how to like do both methods?
No? Whatever method you want to use.
Wait, so we don't have to
I
use
don't
the
like
guess
to
and
guess.
check?
I don't know.
Use whatever you want. There's also another one I could show you, maybe later tomorrow I'll show you, but there's another one that I know pretty well. Let's do 10. So you said to finish up. Now this one's kind of the reverse of the last one. because it's not 1. But you see how the C value is already, it's good. The two numbers that multiply get 5 are 1 and 5. That's it. So there's only going to be one choice for the C value. Now, it could be that the negative is here with the 1, or the negative is with the 5. That's really the only main thing you got to think about. So the first numbers that we'll have to multiply to get 6. Well, there's two choices here, 1 and 6, or 2 and 3. Now, I'll tell you, in general, I choose the ones that are closer. Like, I wouldn't choose the extremes, 1 and 6 as much. Generally, the middle ones work a little bit more. So let me try that, 3x and 2x. That would be good for the f. They multiply to get 6x squared. Okay, but I need to check the O and the I. I already said for my C values, I have to multiply to get negative 5. So what do you want to try? Negative 1 and 5? Let's try that. So the O and the I here, 3x times 5 would be 15x. Negative 1 and 2 would be negative 2x. No, that's really close. Do you see that? Oh, we got 13s, and we need negative 13. So what should I do?
Make the 5 negative?
Yeah, just switch the signs. Yeah. So let's change that one to positive and this one to negative. 3x times negative 5 is now negative 15x, and 1 times 2 is positive 2x. And now that gets me to negative 13x. So there we go, 3x plus 1, 2x minus